Hello Internet! Today we are going to be taking a look at how we can create a Mindustry server. So we can host our own Mindustry levels, maps, servers, question mark? Should really think about terms before I start this. So what this is, if you're unfamiliar, Mindustry is a game. It's available on itch or Steam. I will link it in the description. It's one that I've been playing recently. And it allows you to self-host your own servers. One of the fun things about that is we're going to take a look at how we can do this inside of Docker, inside of containers. Docker is a containerized environment that allows you to recreate a set or an image of an environment from scratch really quickly. So the useful thing is you can kind of template what you would like to create, give it to somebody else, move it to a different computer, and run the exact same thing and get right back to the same state without having to worry about anything else. It also has this really nice effect of being able to tolerate a lot of weird things that you're doing. So I can destroy my server and instantly create a new one just by setting up a new image. It makes things a little bit more resilient, and it also just is kind of a nice, fun, and easy way to run things. It's sort of how I run all of my services. So one of the fun things with this is actually a relatively straightforward process for setting up something for, say, Mindustry. And you can also take it and use it for most other games that you might play. Anything that allows you to self-host a server that gives you a server binary, Minecraft, Factorio, etc. Similar things will apply here. It might require slightly different applications. You might have to do things slightly differently. You should be able to apply, though, what we cover here to solve all of that. So what we're going to try to do is just get a really simple server setup. We're not really going to do too much beyond that. It's just going to be the bare bones to kind of get things running. And we can talk a little bit about some of the fun ways we can expand that. One of those is going to be downloading a binary automatically, which we may or may not get to depending on how long this takes. This is sort of where we are. This is the itch page. Again, link in the description if you're curious. Or you can just go and grab it on Steam. It's there as well. So this is their documentation for how to actually run servers. So this is just taken directly from their wiki. And the interesting parts are we need to grab a server or server release.jar. These are available on GitHub or on the itch page. So just down here, there's a zip file that includes the server files. So you just grab that and you're ready to go. I have already done this step, so it's already sitting in a folder that I would like to use. It has a CD or change directories into the correct place, and then use Java to run the jar file that they give us. Then once that's happening, we can run host and host a specific map name to get a game started. What we do need to keep in mind is that we actually need to expose this server on port 6567 for both TCP and UDP. If you do just one, this will not work. That is an important caveat to this specific setup. That is not true for every server. So let's get started. What we're going to do is jump into VS Code, and I just have an incredibly empty thing. There's nothing here. I'm just going to clean up those extra windows, and let's go and create a Dockerfile. This is typically where you're going to start, and sort of what a Dockerfile does is it defines a series of layers similar to an onion or an ogre that define how to set up your image, how to set up your environment. Layers in this case are just a step-by-step instructional list of do this thing, change this environment, import this thing, run this command, copy this file, those kinds of things, and then save that state into an image, and then we can recreate those images at any time. Every single line that we add into this file creates a new layer, a new image that we can use. Typically, only the last one is the relevant one. That is typically the one that you're going to be naming. All of the other ones do exist, though. They're just intermediary layers. So these typically are going to start with a from file. This gives you the image that you're going to be basing this on. You don't necessarily have to base a Dockerfile off of any existing image. You can go from scratch if you would really like to. We're not going to do that. So what we want is openjdk. So we can run the openjdk stuff, and we want 25-slim. So this is just giving it the actual thing. I have an extension here for Visual Studio Code that is actually going and reading Docker Hub, which is where all these images are actually located. There's a container registry that stores all of these containers that are tagged up in that repository. In this case, we want 25 slim. You don't necessarily have to use this slim image. The reason we're using this is because the slim one is 200 megabytes, and the one without that is about 3 gigabytes, and it's just a lot larger. So this saves us some space. It makes things a little bit faster, and we don't need any of the other stuff. A lot of the additional bits that come with a more general image are going to be like development environment things for actually building and compiling Java code, which we don't need to do. So that should get us our image. And then we're going to run a copy command. Copy is going to take something from a source directory and put it into a destination directory. So we have a server file. So let's just grab server.jar and let's put it at the root directory. So in this case, we are copying. Let's make this just a little bit bigger. We're copying from here relative to our Docker file, relative to where we're actually going to be building this image from. We are copying server.jar, and then the path on the right-hand side is actually the path relative to the image internals. So think of this like another, in this case, it's going to be a Linux-based operating system. By default, most containers are going to be Linux-based. There are options to do Windows-based containers. You probably never want to use them. We're not going to really get into why that is. Typically, you would use Windows-based environments only for Windows-specific tasks. If you have things that specifically require Windows things, it's not really useful for most cases unless you explicitly need that. So for default, typically you want to stick to Linux stuff. We're also implicitly using x86-based images instead of ARM. That's just a side effect of me building this on a desktop. This can change. So you can build ARM-based things, like if you're on a MacBook, those have ARM-based processors. You may want to run an ARM-based container. Again, it's kind of up to you. So we've copied this over, and then the other thing we need to do is actually give it a command to run when we run this thing. So there's two things you might see. You might see entry point and you might see CMD. CMD is what we want here. Entry point is typically going to be parameters for when you're actually entering in as an executable thing. I'm not really intending to do that. So the command for this is java-jar. And then we want to run where we copied it onto our server file. So importantly here, everything inside of these images is relative to internal what's on the container. So if I start referencing other files on my computer, other things that I know exist, this will not find them. This is relative and isolated to what's in the container. So the only reason we can use this server jar is because we copied it over into the specific directory prior to doing this. Without that copy, this wouldn't work. Even though the file is right there on our computer, that's not how containers work. That can kind of catch you out a little bit if you're just kind of figuring these out and just learning about them. My terminal's being super weird. Let's go and get that back. Cool. So that's it. That's all we need to do in order to get this working. So what we're going to do is run a Docker build, and I'm going to tag this as a Mindustry server. In this case, it's version 146, so we could do like the 146 or something like that. I'm just going to tag it generally. just because I'm only going to use this locally and this is just easier. And then we need to give it a path to a Dockerfile. By giving it dot, it's going to find Dockerfile inside of the current directory, which should be the one that we just wrote because that's where we are. So if we hit enter here, you can see it builds a bunch of things. You'll see we have from, it's going to do that. It's going to go and copy over the server jar and do all the other bits. If you're running this for the first time, this will look different. Because I've already kind of been testing this just to make sure it works, things like pulling the original image will have to happen first. So, for example, this openjdk image that we are using, that is the base of everything that we're doing. We need to pull that down first so we can actually reference it and build on top of it. You will see that get pulled the first time you request it if it is not already on your computer. So every one of these images has to be based on local stuff. If it's not available locally, it will go out to Docker Hub or another container registry and try to find that image that has the image and the tag associated with it and labels. So that's how that works. What we're going to do now is, now that we have a working image, I can actually just run this. So I'm just going to do Mindustry server, and that should be all we need. Now you can see we get this, and now it's saying, okay, server loaded, type help for help. I can type things and nothing happens. The reason nothing is happening is because I haven't told Docker to forward my inputs into this image. So it's not interactive. I can't type to it. We also haven't exposed any ports. So even though this server is here, it's still not going to work. What we can do though is we can make this interactive. So do -it. This creates an interactive terminal and forwards your inputs into it. And so if we do this now, I can say host. This is coming directly from the commands here. So host, the map name, and the mode that you would like to host it in. In this case, I'm just going to host something. Well, if you just run host, it just hosts a random map. And we can do that. So now, if I go back here, you can see we've hosted the mud flats. It's loaded the map. It's opened up a port on the server at 6567. So we should be able to connect to it. So if I go and open up Mindustry now, go to play, click join, add a server, and click on localhost, nothing happens. So this doesn't work. The reason this isn't working is not because the server isn't running. It's not because the server isn't working. It's because Docker by default is going to isolate your containers onto a separate network. And Mindustry and everything else on your actual host machine can't see that. There's no way for it to actually know that those are there. This is because the default networking for Docker is what's called a bridge network. In that case, everything is internal unless you explicitly bridge out ports. There is an option for doing host-based networking, but that is not something I would typically recommend. It kind of breaks the isolation that is what makes Docker nice. So instead, what we're going to do is just back out of this, go back to our server. We're going to press Control-C. That will cancel this, and you can actually see when I do a Docker PS, our Docker container is gone. There is no server anymore. It's completely gone. Everything that was there has been cleaned up. This does have side effects. So if you are intending to save state, save a map or something, recreating and destroying your servers every time will completely delete that. There's ways to get around that. You can either mount volumes or you can persist the actual container that you're creating. Both of those will work. In this case, we did neither of them. If you want to see sort of how I do that, I do have an option or an alternative video, I guess, where I've done this with Minecraft. We actually are hosting volumes. In this case, I'm mostly focusing on sort of the fundamentals. So we have this. Our run command looks like this. So we want to expose a port, which is 6567. And internally, that's on port 6567. So what we're doing here is creating a sort of key value map between our host and our internal image. So we can actually map these onto different things. It also enables us to, for example, run multiple of one thing that would typically share a port onto multiple different ports on the host machine that we're running. This maps the typical TCP-based TCP-based ports. If we want to do UDP as well, which is required for Mindustry, we also need to map that. So 6567/UDP. This is a sort of custom thing that is required from Mindustry. It will not work without it. But this exposes port 6567 for TCP and for UDP. TCP is the default in Docker. UDP, you have to give it that /UDP. And so now, if I host this, you can see now we're on the archipelago. I go into play, join a game, and you can see now my local host is on archipelago. There's 0 of 30 players, and I can jump directly into the game. So I'm already here. Everything's working. And if I actually go back here, you can see that I've joined. So we actually have a full host connection here. All of this is running in real time. We can do all the normal things. And that's that. So let's exit that. We no longer need that. And you can see I have disconnected, close the connection, and that's everything that we need to do. The other thing that's kind of interesting here is we do have this. So Docker PS is going to actually list the currently running containers. And this will give you a really brief overview of sort of what's actually happening on this server. So in this case, we have our TCP port that we're forwarding, and we have our UDP port. If you don't see both of those and you're trying to set this up and you're wondering why you can't connect, that's probably a good place to look. So it kind of is sort of where you'd look. The other useful things in this box are this container ID. You can use this for looking up things like logs. So if I copy this and do a docker logs of that, we will get the entire log file that we just had. So it's going to print the entire thing. You can also use the actual name of the container, which you don't give your container a name, it will get assigned a random 2-word one, or you can give it your own name. And this will perform in exactly the same way. They're just 2 different ways of accessing the same information. So that's how to, I guess, set up a server, make it so you can connect to it, and actually do things on it. If I go back here and do a Control-C, because I have specifically attached as an interactive terminal, if I do a Docker PS now, the entire container is gone. We can list a bunch of other containers, so PS all, and we'll get a whole bunch of things here. So you can see our server is still there, and we should be able to still start it, I think. Yeah. So if you want to restart your server, you can use docker start and then give it the container and it will restart it. That gives you an option to kind of resume that server, or restart it if it started without completely recreating something. But something to keep in mind with containers is that they are ephemeral. They will go away. That is sort of why they're really cool. It's why they're really nice. It's also one of the reasons why they can be a little bit frustrating. If you're intending to store state, which typically game servers are, you can run into some issues where you no longer have that state. As soon as this container goes away, all of that is gone. There is no way to get it back. So that's something to, I guess, keep in mind. Again, if you want to do that, there's ways to kind of preserve things, especially on a local machine when you're not running in like a big server environment. Things like volumes will allow you to kind of persist things onto your local disk and actually access them. But we're going to kind of skip that for now. I think that kind of staying here for now makes sense. If it's something you would like to see, either check out the Minecraft video that I did about running a Minecraft server in Docker, or leave a comment and maybe we'll revisit this. But I think that's it for now. So thank you so much for watching, and I will see you in the next video. So till then, see you, internet.